Welcome, and thanks also for the organization. Congratulations on the environment, because I think it's very nice to be here. And it gives us as speakers a chance to stand in the footsteps of James Bond, right? Who is going to perform this theater as well. We're going to talk about data science and data management in the enterprise. And ING is a large enterprise. It's an international bank. And I want to fall back a little bit on our presentation of this morning. This is a picture that's already presented by our chief architect, Henk Kolk. Who has seen this already? Is familiar with this? Not so many people. Well, okay. Well, actually what this says is ING wants to be an experimental enterprise. And what's an experimental enterprise? It's an organization that is flexible and agile and is doing work in a data-driven way to make it better for customers to experience their services. So based on a little experience, we want to increase the level of service that we offer to clients. We want to offer better products to them. That's in a nutshell. And what is right at the top of that? It's a building block for that enterprise called data science. And well, I don't know if it's on purpose on the top, but I think it's a very important part of that, because if you want to do data-driven work, and if you want to base your next offering to customers based on actual data, you have to implement it in your entire organization. So data and data science and the people who work with the data are very important for that. I'm going to give a little bit of overview of that in this presentation and explain to you about what we are doing and how we're doing that. Then Natalino will take over and give a concrete example of that. So let's get started. And first, one step back to the strategy of ING. And I have one slide about that, and there's this one. This is the strategy of ING on one page. And our purpose is to empower people to stay a step ahead in life and in business. Well, that's a nice statement. But how do we do that? Well, we do make a few customer promises. One of them is, for example, to be there anytime, anywhere for our customers. So it's already a very important step if you think about the data that we are offering to our clients. And how are we actually doing that? Well, we have a few strategic priorities. And if you read this, and so this is not, again, it's not the IT strategy or not something that is locally implemented or nobody knows about. This is the big global IT strategy for every customer and employee of ING. On number 2 of our priorities is we want to develop analytical skills to understand our customers better. Which is actually quite interesting, because this is so important that is this for ING, that we actually put this right on top of our top strategic priority list. Another interesting one is we want to think beyond traditional banking to develop new services and business models. And again, this comes all down to what we want to be as the experimental enterprise, and data science is a very important part of that. This strategy was actually published in 2014. And since this has been launched, there's lots of initiatives already being implemented at ING. And one of them is, for example, that we want to create a data lake, which is a central data environment, which I will talk a little bit more about that. But also, what is even more important, since this strategy was launched, the whole concept of that data is important to us and that we are actually a data-driven organization, it's become part of the mindset of a lot of people. And a lot of people are actually thinking about that and are doing stuff with it and are working with the data and are thinking that data management and things like big data and data analysis is very important to us as a company. So I just picked a few quotes of some of the thought leaders in our organization, some of the actual business leaders actually, who are saying things like this. Data is a valued asset. It's the new oil of banking. So it's data that makes the bank go round. It's so important for us. Based on data, we can offer great services to our customers. And we want to be the next generation digital bank. That's actually a quote from our top CEO. And he is also talking about data management and data analytics in a way that is unknown to us in the past. So yeah, I think it's really an interesting organization to be with if you are interested in these kind of things. My own background is artificial intelligence, and I suddenly see in a bank all kinds of initiatives popping up that have to do with my academic background, and that is something that I have never experienced before. So what data are we actually talking about in the bank? What is it that we have available? Well, this is a nice diagram of a classification of the data that we are actually dealing with and that we can do interesting things with. And right at the top is the party data, and maybe that comes naturally. Who is a customer of ING here? Whoa, that's quite a lot. Well, to you guys, rest assured, and you can be safe that right at the top, the top priority is the party data, and parties are individuals and businesses that are customers of ING, so it's customer data. And yeah, that's obviously our top priority, to do that well, to do data management well on that, and to do proper analytics on that. But we go a little bit deeper, then we see the product data and the agreement data. A product is something that you can take from ING, so a mortgage or a loan or a savings account. And agreement is the relation between a product and a party. So we have individuals who have several loans, and we have businesses who have several maybe mortgages or savings accounts. And there's don't underestimate the complexity of the arrangement and the agreements, because what if there's a mortgage which is shared by two people across 3 houses, for example? All those kind of complex relationships are there, but they're properly managed, and they are right at the top of our strategic agenda. But you can see this as the kind of the structured data that we have. It's all rationalized, and it's all you can draw it in normalized data forms. But if you go a little bit deeper, you can see that there's all kinds of different kinds of data at the bank, which is actually very interesting for us. So, for example, the transaction data. Every transaction is an interesting event that we can do something with. We will hear a little bit about, for example, fraud analysis when people are transferring money from one side to another. And transactions are huge, right? We have enormous amounts of people sending money from one party to another, in iDeal, in credit cards, across the whole world. And we also have things like stock exchange transactions, which are even faster, which have to be processed even faster than a regular bank transaction. So if you talk about not the static data, more of that what's here, but we are talking here about more the streaming data and the fast data, which I would like to call it. And we go a little bit deeper. We also gather data from other sources inside of the bank. For example, well, you see the reference data and the pricing data. So that's data that we are not actually producing ourselves. We are taking it into our own organization. Country codes, currency codes, exchange rates, stock rates. We have a small. Well, not everybody who's a bank customer of ING also has a stock exchange account, but they are very important to us because we want to offer them the best services to do their stock management. But that means you have to really offer a high quality of service based on the stock prices, which are fluctuating every millisecond. So that's really something that we have to be very careful about. And on the downside, we have the operational data from our own systems, because one type of thing that we also want to improve with data management and with data science is our operational service and our operational service level, and thereby our level of costs for keeping our systems up and running. And that can be very much improved by taking a good look and by producing interesting algorithms on our operational data and our sensory systems for our infrastructure. All right. So what do we want to do with data? What are our use cases? I divide them in 3 parts, actually. First of all, we are a bank, so we have to be compliant in a lot of ways. And maybe that's not the most sexy part, but it is the most important part, because our data is actually going to a lot of organizations that are our stakeholders in the financial services sector. So we have to produce reports to, for example, the Dutch Central Bank and the European Central Bank, and to the tax offices, and that has to be perfectly correct. It has to be, highest quality possible. So data quality and data lineage are requirements which are extremely important in that sense. And so one of the things that we are actually now really getting an improvement in data quality and data lineage is that those requirements are increasing. Right? If you have all kinds of laws coming in, and those are becoming much more difficult to follow if you don't have your proper data quality and your data management and your data governance in place. So extremely important for us as a bank. Second, if we look at our customers, we want to be omni-channel. And that is, again, falling back on our anytime, anywhere strategy. We want to be there for every customer at any point of what they want to interact with us. And we want it to be a seamless experience. So if I want to open a bank account, for example, I could fill in a form on my computer. I could also do it on my cell phone, on my smartphone, or I could walk to an office next door and talk to an employee of ING and go over the data with this guy. And everything has to be seamless. So if I do one half on my computer and the other half on my mobile phone, it should all work together. And for that, it's really that's our ambition, right? And for that to be in place, it has to be what we have to do is get our data in one place and make it available to any channel, what we call it, mobile, the branches, the offices, the mobile website, any channel or a help desk employee on the phone who is interested in that data. So data management, again, a crucial aspect of that kind of use case. And on the right side, we want to be more predictive. And what do we want to do? We want to offer new kinds of service to our customers to help them improve their financial situation. We want to offer them advice based on their own data, and maybe other data from other customers, or anonymous obviously, or from the outside world, to offer them advice. Hey, look, you can save some money, or you can reduce your mortgage, or you can do other interesting things with your data. Other people in your situation would probably do this, and look at the financial market. We can offer you this advice. And for that, we have to really improve on our data management, but also on our data science capabilities in terms of machine learning, predictive analytics, those kind of things. And that also starts with all the data that we have at the bank, because the more history you have and the more high quality data that you are gathering, the better the predictions that you can make for the future. And for predictive analytics, you can also think about use cases that we will hear more about later. And that is, for example, fraud detection. If you talk about cluster analytics and anomaly detection, that's also a kind of predictive analytics or machine learning algorithms that would help the bank become more stable and more secure, and that we have less fraud in our organization. All right. So what are we actually doing about it? Because we have lots of ambitions. We want to make the data available. We have the data somewhere in our organization. But what we need to do is cluster it, and we have to make it available. Well, a few initiatives has been launched for that, and one of the important ones is the data lake. And that is something that looks a little bit like this. And I'm not going to go in detail in this picture, because this is a very detailed one. This is created by IBM as a sort of a reference architecture, which we used to set up our own data lake infrastructure. And I will simplify it a bit, and that is giving us this picture. What is a data lake? It is not a data lake which we dump all the data in and good luck with it. No, actually it's a collection of tools and infrastructure and software components that help us structure the data and put it in place for the type of data that is there and the type of usage that we want to achieve with it. And you can see that we, on the left side, we have our core system. So we have the systems which are responsible for their own part of the bank. For example, a mortgage application or a savings account application. And on the right side, we have the analytical tooling that we want to, put on the data to make these interesting use cases possible. And in between, we have a few components which will make that possible depending on the kind of use case that we have. So, first of all, when we talked about, for example, the compliance and regulations that we have to apply to, we have to do that in a very structured way with data lineage. So we have to be able to see where the data actually is coming from. Every step that is being taken care of the data, we have to be able to reproduce it. And we do that in an enterprise data warehouse. So think of this as a normal data warehouse, only on an enterprise level, structured data and tooling, for example, the ETL that produces the data and that stores it in a central data warehouse. And for the more ad hoc and analytical things, and for the machine learning and for the experiments that we want to achieve, we have a exploratory data environment, including an archive, which is a Hadoop cluster. Also part of the data lake, but that contains more sort of the raw data that comes in through our core systems. How does the data come in? Well, currently, if you have to be honest, a lot of the bank is still built on batch files. And is that a problem? Well, not really, but we want to be more real time. But currently, a lot of data coming into the data lake is coming in from batch files. So on a daily basis or maybe an hourly basis, we get a huge export file from one of the core systems. We store it in an archive in our exploratory data analysis. We keep the history over here, and then we process it and we store it in an enterprise data warehouse to do official reporting on it. Report tools are over here, analytic tooling are over there. And what kind of technology are we using for that? Well, I gathered a few technologies that we are actually using in production right now. And probably there will be more of this coming up. And another goal of this architecture is also to be flexible. So, for example, we have now some people who like to work with R as a analytical tool to do machine learning on a data source. The data is coming from a Hadoop cluster, but maybe in a half-year time, R would not be sufficient enough. We want to do more data analytics, and Spark will come in as the next generation computing engine to do massive parallel processing on the Hadoop data. But as you can see, we are actually quite far already with setting up this data lake, and this technology is already all in production. We will dive a little bit deeper into this part in a few minutes, which is the real-time streaming component, and which is built on Kafka, Akka, and again Spark as technologies. So last thing is, how do we do this? Well, what kind of people do we need? Well, obviously, if you are setting up this data lake, and I've been involved in this for the last year, sort of. We need specialists. We need Hadoop specialists. We need ETL specialists, and we use IBM DataStage for that, for example. We need database specialists who are managing the Atresia environment. But we also need people who actually are able to perform analytics on this, and that's actually maybe the most difficult part of it. So we need data scientists. And what is a data scientist? Well, I found this nice diagram from Drew Conway. And this gives a nice overview of what these people have to do. It's actually 3 skills combined in one person, namely hacking or programming skills, combined with mathematical and statistical skills to do algorithms and to do machine learning, and substantive expertise, which is the business knowledge, but also the soft skills and the skills to be able to communicate with other people. Those combined will give you a good data scientist. And this, and as Henk Kolke already mentioned this morning, we are not training people and we're not recruiting people to do just one thing, and that is program in Scala very well, for example. In this area, we actually train and recruit people to be able to grasp the whole picture, to be polyglot programmers, and to be people who look beyond their traditional borders of what they are doing. Okay, and one of the people who is filling that profile, I think, is my good colleague and friend Natalino. So I hand it over to him, and he's going to talk about the streaming part more for us.
Can you hear me? No? Hello? Yes? Yeah? No? Hey. Yo. Hey, it's going. All right, so let's see if I can put this on full screen. What is that Windows stuff on top? Oh my God. Let's try to get rid of that first. Okay. Well, thank you, Bas. And my name is Natalino Busa. I'm a data platform architect at ING, and I'm gonna tell you something about streaming events with Spark, Cassandra, and Akka. So a couple of technology that are coming up lately. So yeah, a while ago I was having some drinks with a couple of pan-dimensional beings, and yeah, we were talking about what could be the answer about the universe and you know, life and everything. And they told me that cool place, you go there and there is this big machine and it gives an answer. And the answer was 42. I said, oh, good. Let's start from there. Sounds like a good beginning. Well, that place was a bit more remote than ING was in. You needed to pass a couple of dimensional portals to get there. But then I got called by Henk Kolk, and he said, okay, nice. So we know the answer, but we have the data. So do it so. Make it happen at ING. I said, okay, let's give it a try. So then I went to the ING, and there was this story about data, and suddenly it became clear that the data was not just one type. We had data which was spanning like years, data which was coming up really fast, events, transactions, sessions, clicks, and so forth. And we had all that extra dimensions, which were the users, the customers, which were experiencing all sort of you know, journeys in terms of products, in terms of services of the bank. And all those different sorts of data were coming in together. And well, it was actually kind of a challenge at the beginning to say, okay, let's make it happen, because what does actually has to happen? Because we see those different data types, and we had that, we talked about big data, but we also saw that there was fast data. There was data coming in at high speed, thousands of transactions per second, and those two things needed to be combined. So why do we need to combine big data and fast data, and why data is so important for ING? Well, first of all, because as Bas has already told, but I would like to repeat it, ING is about empowering people to go a step ahead in life and business. And that means to take informed decisions. Now, informed decisions, they only come if you actually are able to access the data and to get good insight out of your data. So why fast data? Fast data is there because you need to get relevant information. The information must be up to date and must deliver insight for all of us, for the customer first. And the big data part is that we need to get good insight. The quality is very important. Therefore, we need to analyze the data. We need to build models that actually mean something. It's not enough just to to name the petabytes, you need to make good models, good propositions. Now, these propositions, they require sometimes big data, not all the times. But big data is there also to learn, to cluster, to categorize, to aggregate this information and make it so in a way that actually is meaningful for our services, for our customer, for our products. So if you think of it, then it came to me the idea that actually there are a number of technology today which not by coincidence are all Java based, or at least JVM based, which are Akka, Cassandra and Spark, which actually could build the foundation of such a great system where you could combine fast data and big data. And well, let's start by Cassandra. Cassandra is a key value store and has replication built in right from the beginning. Therefore, it allows you to have a resilient and distributed data set that can span across multiple data centers, even distributed geographically across several regions on the planet. ING has a number of data centers in the Netherlands, but you see also other companies like Microsoft having data centers in Europe, in the US and so forth. So what do you get with replication? Well, replication allows you to be more resilient with your data, allows you to be fast. In particular, Cassandra is one of those databases, is a NoSQL databases which allow you to be fast on writes and also pretty fast on reads as well. Well, so you have a component where you can store all the data, you're distributed, you're resilient. What about Spark? Well, Spark, it popped up as a pretty smart idea. There was this guy called Matthijs Aria. He said, hey, why don't we take that Hadoop thing and we run it in memory? Well, sounds like a good idea, and in fact it was a good idea. And there are lots and lots of people now that are actually working on Spark, simply because it gives that tremendous acceleration on those traditional big data queries which were running on Hive and Hadoop. So with Spark you can query, you can aggregate, you can analyze all the data. Now that's an interesting idea. So you have now store all the data, distributed, resilient, in a resilient way, and you have analyzed all the data. And it's also done in a distributed, resilient way. The third thing was actually another little requirement that I got while I started this project was, yes, it has to be all the data, but also please deliver answer in milliseconds, because who does seconds? Now we need to go really fast. So let's put the millisecond in the picture. Well, it turns out that if you go with Spark, you can go from, let's say, terabytes of data down to seconds. So you can be extremely fast when it comes to what they call it micro batches, up to seconds, and go all the way up to petabytes of data. And however, there was that little segment which was the sub-second, or let's say the millisecond response, which you might want to have in some use cases, like for instance detection, notification, and so forth. And therefore we took another technology. I suggested Akka as a technology that could be added to this flow and would allow you to have actually another paradigm, which was an actor-based paradigm, moving around events from actor to actor, exploiting the models and the aggregation, the idea that were coming from the Cassandra Spark combination. So we put it all together, and then I said, okay, that's nice. I mean, there are interesting components, and I was there kind of squeezing my brain's out trying to figure out how would we put out actually all this information together and those things. So I was actually in the bathroom trying to hang a clock on top of the toilet, and then at a certain point I actually slipped down, and all of a sudden I thought I saw this. Said, "Oh my God! Great God! This is it!" Huh? So I can actually start to see how you could put those things together, and so I took the Cassandra data store, I placed it in the middle, and I said, "Okay, we're gonna send there all the data, events, but also files and also batch data, whatever we need to enrich and aggregate our experience with all the data sources which are required." Well, what you could do with that already just by using that component was just to have APIs. So APIs, they just, in fact, they emerge almost automatically if you would have such a distributed low latency data store. You could create beautiful experience on mobiles, on web, and so forth. Then I put the Spark system on top, and all of a sudden, all this data comes to life. So you can actually take it and analyze. The data becomes model, becomes experience, becomes all sort of interesting insight. Yeah. So data modeling, it's great. And then what you can do with those models, well, you could actually use for scoring. And then Akka is there for the tremendous speed, the thousands of transactions per second, the millisecond responses. And what you could do with that, well, you could do notification, you could do alerting, you could really be close to the customer experience as it happens, wherever it happens. So Spark actually is coming out as a very mature component these days, which is basically built out of three parts. There is a Spark engine, that bright idea of saying, let's take Hadoop and let's put it in memory. Yeah, they just changed a few names, but that's essentially what it does. And there is a top part which is composed out of a number of modules, which effectively unify data processing across a number of, let's say, paradigms that in the past they were seen as completely separated. So you could do SQL, you could do machine learning using a machine learning library, but you could also do graph analysis. You could apply some micro batching strategies and stream the data and chop it in blocks and so forth. But instead of using like 20 different tools on the Hadoop landscape, now it's all part of the same platform. And it actually is available in 3 different languages, which now have become actually 4. Yeah. Originally it was Python, Scala, and Java, and actually R has been added to the equation. So you could actually mix and match in 2 different ways. You can mix and match languages, and you can mix and match paradigms. You can write 1 line of SQL, 1 line of machine learning, 1 line in Scala, and 1 line in R. Well, you could, potentially. The other part which is really awesome is actually that we see that Hadoop was coming up with the idea you have to use HDFS, you have to put the data there. But in fact, why? I mean, we also realize that the value of SQL databases and NoSQL databases is also very valuable. So why would we say, hey, we need to run distributed computing, but just on HDFS? That's not the case anymore. In fact, actually, I've seen more and more examples of companies which are using Spark and distributed computing just on NoSQL, just on Cassandra, or even just on relational databases. These days there are connectors and exporters for a variety of systems, Redis, SQL system, Cassandra and so forth. And HDFS is still there. So what you could do is you could at the same time take the large amount of data, but also be very close to your operational systems. Cassandra is there for APIs. What is actually greater than having a processing engine which is running on the data which is already located on Cassandra? And Cassandra is distributed, and that means that you actually can take the data and move it to another data center, and that replication, you get it for free, yeah? But what if you take actually another data center, and in that data center, you actually put Spark on it? Well, that means actually that without doing anything at all, by construction, you get a system where you would have replication, operational qualities like low latency to your data, and at the same time operates on terabytes of data and understand and grok all your data. And if you want to, let's say, offload the system, you can do that because now it's on a different cluster. Or let's say it's in the same cluster, but it's on a different ring, right? So this concept of, let's say, replication and resiliency goes now beyond simply the fact that you have a localized cluster in a single rack or in a single data center. Here we're talking about multi-center replication with potential multi-center coordinated data processing, also done in a fully distributed way. Wow, I would like to add. So, if you can do that, there are a number of things that come out of the box which are available because now the data can be scanned and aggregated. And as Bas has referred, you could have things like, hey, the voice is... okay, I assume you haven't heard anything of what I said, right? Okay, so data science. Data science with the dbScan. dbScan is an algorithm that is actually capable of, let's say, creating structures of locality. Yeah, so it's a clustering algorithm, but with respect to the k-means algorithm that now everybody's naming, this has a couple of very interesting properties. You don't have to specify the number of cluster, and is non-isomorphic, means that actually can have shapes which are not balloons. Yeah, so you can have like sausages as well and other shapes. So why is that important? Because there are a number of algorithms and a number of data sets where going for k-means and making circles is not necessarily the best clustering that you can do. And this algorithm will just look locally, and it's a density algorithm, and it will just connect those points which are close to each other. And what comes out of it? It's a graph, right? I know this one was a bit lame, but still, it's good. So there is this topic called the topological data analysis, that if you haven't heard of it, it's the bomb. I mean, you have to try that up. I mean, this is an example of the Netflix dataset where actually films which have the similar, let's say, characteristic, like the thrillers, the family movies, the cartoons, they aggregate and they move in the same space of this, in the same region of this space. Topological data analysis is one thing that you could do with matrices, and for instance, the dbScan is a good idea once you have done the topological analysis to actually automatically define your clusters. And this is real data science. You will get a fully automated way to cluster your movies, in this case, according to to the characteristic of the movie. But you could also take, for instance, other example. For instance, you check in a number of venues, and then we start to build a sort of a history of venues and visiting venues. This applies if you squint a bit with your eyes. Of course, this is venues, but you can apply that as well for sessioning databases. You can apply that for transactions. You can apply that for forms that are applications which are presented through website and etc. So one of the greatest things that you could do with this sort of techniques is you can find clusters. And one way to find clusters is apply the DBScan algorithm across all those points. Now the points, if you take if you think that the data is located in Cassandra, and now that you have sorted nicely all those experiences, all those events, and you have separated and partitioned them per user, you immediately see that applying this algorithm, you could see what are the typical cluster for a user. But you could do the same for a collection of users, for friends of this user, and so forth, or temporally saying for the users which were in the same venues of the same user up to 1 year ago, etc. So you create all these very rich features. And remember, context is fundamental. If you want to build good quality data science, don't go and say, aha, that's a single point, that's really bad, this is what we need to do. No, you need to look at big context. You need to look at the data in its globality and start to make the case more robust. And algorithms like that create robust, for instance, anomaly detection, robust clusters, and so forth. So this is Scala code. It's a great language. In 4 lines, you have actually applied the DBScan for all your millions of users right there. You just have to write that. You run it on your cluster. You're done. You can go for coffee. So with Spark, actually, you have 2 ways of doing that. You have, let's say, algorithms that take all the data and actually try to find a sort of aggregated result. These are the algorithms that you will find in the ML lib of Spark, and there are a large set of ideas and algorithms that you can actually apply simply by saying, hey, I have a distributed data set, why not just simply applying the same thing over and over again for all those users and partitions. So this actually can be summarized like MLlib data science versus just RDD map function that you can figure out yourself what best fit you and for the purpose of your analysis. And a small remark, just to summarize this second part of the talk. Once you have this model, what would be a way to proceed is, of course, with Spark and Cassandra alone, you can do a lot. Yeah, you go down to seconds. You could do your micro batching. You train, you score, you can do all this stuff. If you want to go down to the millisecond, then you have to add a fast layer built with, for instance, with Akka. Well, you could do that, and that's the same picture of our flux capacitor, but a bit folded over. So you have still the Cassandra and the Spark clusters underneath, and on top you could say, okay, I have my events. They come in, they get into some input actors. I have some transformation actor, and I put those actors at work to produce new events. And those events are your APIs. They connect to your APIs. They actually allow you to build notification, to build SMS messaging, to build email email production in an automated flows and all this sort of very nice way to interact with your customer. Or you could use them to open and close your garage door. That's also an option. Well, we did a small wrapper around Akka at ING, and it was a nice experience of building a little, let's say, open source component. And what this component actually does, we built a sort of a REST interface where you can actually generate actors in Akka, but dynamically, so at runtime. So you just write post, you create an actor, that actor is actually added to the data flow, and you don't need to program anymore. So that actually is a way of it's sort of an actor system as a service. Yeah. I heard worse than that, by the way. I heard also what was it? Guessing as a service. 50% chance of success. Anyway, well, that's a nice idea we had. Of course, it's just minor. I would say that the big part is it's down below. It's Akka as a library, which is really solid. It's Spark and it's Cassandra. So to summarize, we described the flux capacitor with Cassandra, Spark, and Akka. And actually, if you listen very carefully in the movie, there is Emmett Brown that says, "I will build it with Spark, Mesos, Akka, Cassandra, and Kafka." But you have really to listen very carefully for that. And by the way, that goes under the name of the SMAC stack. So if you heard the SMAC stack, that's Emmett Brown at work. There is a longer talk on that with some demos, some code, some GitHub exercise on O'Reilly. It's a webinar. If you wanna join, you can actually subscribe. The date has changed. It's now the 16th of December. And it's something where you will get a bit more insight of how you actually connect those things, and there should be a demo as well. So I would like to thank ING for this great idea of taking this pan-dimensional concept of analyzing all the data and making own at ING, for the vision and strategy of an event-driven bank, and of course to a great community of colleagues which are really awesome and that have made all this possible. So with that, I would like to invite back Bas.
Any time for questions left? I think so, right? Any questions? Yes?
You guys have different clusters of Cassandra with the same data, right? I just wonder, why do you need that, and why can't you schedule the jobs in such a way that you can have just one cluster?
So it's a bit of terminology thing. It's still one cluster, but there are 3 rings, right? The question is, why wouldn't you do the same with a single ring, right? Well, the thing is that if you do it on a single ring, then if you have APIs, they will at the same time be loaded with, operational load. So there will be calls to the APIs that will exercise the Cassandra cluster. And what if Spark starts with a table scan because wants to do, let's say, an aggregated analytics? Then you are on the same cluster and you actually might get some penalties. The fact that now you have 2 rings, so the cluster is actually distributed across 2 rings, allows you to have the cake and eat it. Yeah? that's where resilience is at work and data replication. So excellent question about eventual consistency and the multiple ring replication. We can have a good discussion there.
Okay. We just got the end sign, so if there's questions left, we'll be here or at the ING stand. One remark: don't forget to rate our session in the app, because I heard that we can go to the States if we win. So and thanks for listening, and enjoy the rest of the day. Bye bye.